Up to this point, we've been dealing with solving quadratic equations in one variable, and now we're going to be talking about dealing with quadratic equations that are in two variables. And specifically, we're going to be graphing these quadratic equations. Note, when we're talking about an equation in two variables, so both x and y versus just a single variable, our solutions are ordered pairs. The graph that you see here is the graph of the equation y equals x squared. And every point on this parabola is an ordered pair that satisfies this equation. So when we start dealing with equations in two variables, remember we have infinitely many ordered pairs that satisfy, and so we can make graphs to give a visual representation of those solutions. This is the basic one, this y equals x squared. So 0, 0 is a point, because if for an x coordinate of 0, 0 times 0 is 0, the corresponding y is 0. 1, 1, 2, 4, every ordered pair, so that for the value of x, the y coordinate is that x value squared. Any other quadratic equation, any other equation where we have the highest degree is 2, we're going to be, or anything in this form, is going to end up graphing as a parabola as well. So from here forth, anytime you see a quadratic equation that has this form, you know that the graph is going to be that of a parabola, or this U shape. So when I ask you to graph this equation, y equals x squared minus 4x minus 12, your first reaction should be, this is a quadratic equation. I've got this x squared in two variables, so I know that the graph is going to be a parabola. Okay? It must be a parabola every time you're graphing these quadratic equations in two variables. So if you're trying to make or come up with a graph, a lot of people, it's their standard, go-to method. Find some ordered pairs, and they just always go, all right, let's do the -2, -1, 0, 1, 2, because that's what we always did, or that's what we could always do when we're dealing with lines. So let's see what happens when we do this here. Okay, so if you substitute -2 in for x, you're going to have -2 times -2, that is 4. -4 times -2 is 8. So you have 4 plus 8, that is 12. And 12 minus 12 is 0. If you substitute -1 into the equation, I can even write it. We have y equals -1 quantity squared minus 4 times -1 minus 12. So that's 1 plus 4 minus 12. That is -7. If we substitute 0 in for x, we have y equals 0 squared minus 4 times 0 minus 12. That's -12. If we substitute 1, we have y equals 1 squared minus 4 times 1 minus 12. That's 1 minus 4 minus 12, or -15. And then finally, if we substitute 2, we have y equals 2 squared minus 4 times 2 minus 12. So that's 4 minus 8 minus 12, or -16. Okay? And then if we take these points that we found and go ahead and plot them on the graph. So -2, 0 is here. -1, -7, so left 1, down 1, 2, 3, 4, 5, 6, 7. 0, you know what? Let's change that. Let's change our scale. Let's do a 20 by 20. I wasn't paying attention to my numbers here. Let's start over. So because I have this -16, instead of doing a 10 by 10, I'm going to make this a 20 by 20. So each mark will be worth 2 rather than 1. So this is a a 20 by 20 scale here. Okay, so let's try this again. So negative 2, 0 will be here then. Left 1 down 2, 4, 6, 7. Left 0 down 2, 4, 6, 8, 10, 12. Right 1 down, that's 12, 14, 15. And right 2 down 16. So when I plot this set of points, this is what I see. Okay? What I should be seeing is a parabola. The reason that I'm not is because, yes, it's sufficient when you're graphing a line to just use the negative 2, negative 1, 0, 1, 2. But when you start getting into these different shapes, these U shapes, the parabolas, the V's, the whatever, you cannot just use this random set of points. Okay, so when you're graphing a line, you can. And so we often picked these numbers because they're small and easy to work with. Unfortunately, when we're graphing parabolas, we can't just do a random negative 2, negative 1, 0, 1, 2. What we need is a strategic set of points to be able to get that desired shape. Okay? So in terms of parabola, the strategy is going to revolve around that vertex. Okay? Always find the vertex first. Okay? What we've done here, it's just not going to do it. Okay? So let's look at the next slide and let's do it the right way. Okay? This is not going to work. Let's do it the right way. So, the strategy involved. When you are graphing a parabola, you always want to start by finding the vertex. Okay? The x-coordinate of the vertex can be found using this formula, opposite of b over 2a, if your equation is in the form y equals ax squared plus bx plus c. Okay, so your equation has to be in this form where a, b, and c are real numbers and a is non-zero for this to be the vertex. Since this equation is, we can find the vertex. So a is the coefficient of the x squared, so a is 1. B is the coefficient of the x, so we have b is negative 4. So the opposite of b, that would be positive 4 over 2 times 1. So we've got 4 divided by 2, which is 2. Okay? So the x-coordinate of my vertex is at 2. Now we need to find the corresponding y. Anytime you are dealing with ordered pairs, so we know that the x-coordinate is going to be 2, then we need to go ahead and substitute this in to this equation to find the corresponding y. So the y-coordinate then is 2 squared minus 4 times 2 minus 12, or 4 minus 8 minus 12. That gives us negative 16. Okay? So 2, negative 16, that's my vertex. And when we're talking vertex, I don't know if I've actually said what the vertex is. If you're dealing with a parabola, okay, a parabola that opens up or a parabola that opens down, the vertex is this lowest point or this highest point of your parabola. Okay? And so the vertex, when I graph this, I'm either going to have something that looks like this or I'm going to have something that looks like this. But either way, 2, negative 16 is going to be either this lowest point or this highest point. So regardless of whether the parabola opens up or down, we can see when we're dealing with a parabola that, if our vertex is here, we have points to the left of the vertex and we have points to the right. Points to the left and points to the right. So, once you know where your vertex is, We know we have a point at 2, -16. That's specifically the vertex. Then you can go ahead and just find at least one point on either side. So one point to the left and one point to the right of the vertex. And then you know it's going to be a parabola so that you can just make your shape from there. So again, I'm going to do my 20 by 20 here. So I know my vertex is at 2, -16, so down 2, 4, 6, 8, 10, 12, 14, 16. And so I'm going to have points to the left of that and points to the right. So to find a point to the left, I'm just going to substitute any value to the left of 2, right, my x-coordinate of 2, to find my points to the left. So I'm going to use 0, just because that's easy. So if I substitute 0 into this equation, I have y equals 0 minus 0 minus 12, or -12. Okay, so 0, -12 is a point to the left. So that's 2, 4, 6, 8, 10, 12. And here's the deal. You know, when you look at this shape, this U, it's a symmetric shape. Okay, meaning, you know, we could take this parabola and fold it over and have it fold onto itself. If it is the case that you can fold a graph or fold something onto itself, we say that it's symmetric. And if you're looking at a parabola, you see that that fold would have to happen at the vertical line that goes through the vertex. Okay? So if we fold a parabola over that line, it will fold onto itself. That line that I'm talking about actually has a special name. It's called the axis of symmetry. Okay? When we're dealing with parabolas, the axis of symmetry is always a vertical line that goes through the vertex. This is called the axis of symmetry. Okay? And our parabola would be symmetric on either side of that. So for my parabola, if I folded it over this, for it to fold onto itself, since there is a point here, 2 units to the left of the axis of symmetry, there must also be a point over here, 2 units to the right of the axis of symmetry. So you can always just use symmetry to find another point. And you'll see algebraically, so I plugged in a 0. If I plug in 4 for x, then I have y equals 4 squared minus 4 times 4 minus 12, and 16 minus 16 is 0, 0 minus 12. It does work out algebraically as well, okay? And that's something that you really need to keep in mind. Everything that you do when you're working with parabolas, the visual aspect and the algebraic aspect should always coincide. If they don't, you messed up, okay? And the best place to look is you always should start back at the very beginning. So if what you see visually doesn't coincide with what you're finding algebraically, just go back to the beginning, back to the vertex, and just work your way through. Because more often than not, people make mistakes when finding their vertex, and then that throws the whole thing off. So go back always to your vertex. So now we know that we have 3 points specifically, and we can round it out to make our parabola. You know, if we go back to the previous slide, we had those points. But what we had, unfortunately, was just the left-hand side of that vertex. It was a coincidence that this is the vertex, but we had no way of knowing that. We didn't know if it was going to keep going down. It could have kept going down forever for all we know before it came back up again. So it is, generally speaking, not a good strategy to use just your standard -2, -1, 0, 1, 2. You always, when you're working with graphing parabolas, you want to find your vertex. If it's in the form axy equals ax squared plus bx plus c, you can use this formula to find the x-coordinate. Once you find the x-coordinate, you can plug that in. And then knowing that this is your vertex, then all you need to do is find at least one point to the left and one point to the right, and then you can go ahead and make your parabola from there. Sometimes, you know, you will want to be able to find y-intercepts and find x-intercepts. Math, in the world of math, y-intercepts and x-intercepts are pretty hugely important, and in terms of graph interpretation as well. You know, looking at those values and learning how to really understand, how do I find a y-intercept, how do I find an x-intercept, this is going to lead you to bigger and better things in the future. So another strategy that you can use is specifically focusing on these three things when you're graphing a parabola. So find the vertex and intercepts to graph. So if those are the directions, you know you're going to have to find the vertex, the y-intercept, the x-intercept, and then go ahead and use those and anything else you might need to graph your parabola. Okay, so when I look at this equation, this is the key, and we're going to be doing a lot of different types of graphing. So it's important for you to really start recognizing, I see an equation, I know this is going to be the graph. The graph will look like this when all is said and done. So if you see that you have a quadratic equation in two variables, that's got the x squared, and then you've got both x and y, you know that the graph is going to be a parabola. Okay, and then your brain says, well, if it's a parabola I'm trying to graph, I know I always have to go ahead and find that vertex first. So finding the vertex, finding the x-coordinate, go back to your equation. You know, if our equation has the form of y equals ax squared plus bx plus c, then I can find the x-coordinate using the formula opposite of b over 2 times a. Okay, so the value of a is -1 and the value of b is 5. Something I have to, you know, caution you about now. You know, before we were working with quadratic equations in one variable. We didn't have this y here, we would maybe have a number. And when we're dealing with an equation in one variable, we generally like to have the value of a be positive. When you're working with graphing parabolas and you've got quadratic equations in two variables, if you tried to make the value of a be positive, then you would have to multiply all of this by -1. But if you multiply the right-hand side by -1, you'd also have to multiply the left side by -1 to balance your equation. So doing that, you would actually have a negative y rather than a positive y. Why am I saying that? I'm saying that because if you want to use this formula, it has to be positive y equals blah, 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 blah. So if a is a negative number or a is a fraction that you don't want to work with, you have to, okay? Because it has to be y equals blah, blah, blah to be able to use this formula. So back to this. So now we can use the formula. So we have the opposite of b. b is positive 5, so this is -5 over 2 times -1, or -5 over -2, which is simply positive 5/2. Okay, once we have the x-coordinate of the vertex, then we substitute it back into our equation to find the corresponding y. So our y-coordinate is the opposite of 5 halves squared plus 5 times 5 halves plus 6. So we have to square the 5 halves, then take the opposite. So 5 halves times 5 halves, that would be 25 fourths. So this is negative 25 fourths plus 5 times 5 halves, that's 25 halves, plus 6. And then just get out the calculator and let it do, the rest of your calculations for you. There's no reason for you to go through and do that by hand. And honestly, you could even just substitute or type in exactly what you see here. So if we even, type in the line before, if you're worried about making, calculation errors, which some people are, just go ahead and type it in as you see it. Whoops, I'm going to have to go back here. So that would be the opposite of 5 halves, but you have to make sure that what you type in is exactly the same as what you see. You have to be careful with how you input, because how you input it, you're telling your calculator what it should do. And if you don't input right, you're going to tell it to do the wrong things. So when we input 5 halves, the corresponding y value is 49 over 4. Okay? So the vertex for this parabola is at 5 halves, 49 fourths. Okay? So you can plot those values. You're just going to have to figure out what they are. 5 halves, if you do 5 divided by 2 on your calculator, you'll see that that's that is exactly 2.5. And 49 fourths, if you do 49 divided by 4, you'll get 12.25. So on our graph, we're going to go over 2.5 and up 12 1/4. Do the best we can here. So to the right, 1, 2 1/2, up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 1/4. So kind of hard to do. I'll get as exact as I can there. Well, it's around there somewhere. Okay, so my vertex is there. So I know that that is going to either be my parabola like this, or my parabola is going to go like that. That's going to be the vertex. And, while we're here, we can go ahead and talk about whether it's up or whether it's down. If the value of A is negative, your parabola is going to open down. If the value of A is positive, the parabola is going to open up. Okay? So, let's say since A is negative, the parabola is going to open down. Significant in terms of finding these, not really, but it is significant. You're still going to have points to the left and points to the right, but if you know that A is negative, your parabola should open down. So if you find other points and end up with an upward facing parabola, upward opening parabola, then you messed up somewhere. Okay, so like I was saying, everything should gel, and if it doesn't, it means you messed up somewhere. So we know we're going to have a downward opening parabola. Let's find the y-intercept. Okay, so if I'm trying to find the y-intercept, I'm trying to find where my parabola is going to cross over the y-axis. Okay, and so if I'm looking for where it's going to cross the y-axis, I know that the x-coordinate of that point is 0. So anytime, it doesn't matter if it's a line, if it's a parabola, if it's a square root function, it doesn't matter what you're dealing with. If you're looking for a y-intercept, you always, sorry, I'm bumping the camera, you want to substitute 0 for x and then solve for y, because you know it's going to have 0 for the x-coordinate. So if we put 0 in for x, we have y equals the opposite of 0 squared plus 5 times 0 plus 6, which is just 6. So 6 is the y-coordinate of our y-intercept. So I hit the y-axis at 0, 6, 1, 2, 3, 4, 5, 6. And you know, in terms of just graphing, once we have the vertex and one other point, we have all that we need to make the graph because of that axis of symmetry. Right? When we were talking before, we said, well, if we're dealing with this U shape, it is symmetric. And if I fold it over the line that goes through the, sorry, this is hard to do. If I fold it over the line that goes through the vertex, it will fold onto itself. Okay, so this would be this line. This is my axis of symmetry. Symmetry. And so because of that, you know, this was what was that, 2.5? So 2.5 to the left of the axis of symmetry, I have a point here, so there should be another point 2.5 units to the right using symmetry. So let's go ahead and plot that. So half a unit and then another 1, 2, there should be another point there. So I really have everything I need to be able to graph my parabola. Okay? But I was asked to go ahead and find x-intercepts as well. And so when I'm looking at this, you know, I know that my parabola is going to open down. It's going to open like this. And just based on the graph, I know that when I go to do the algebra here, I should end up getting 2 x-intercepts because obviously it's going to cross that x-axis twice. So let's find out what those are. So when we're looking for x-intercepts, we're looking for points that are on the x-axis. And if we're talking about points on the x-axis, every point on the x-axis has a y-coordinate equal to 0. So when we're looking for the x-intercepts, we know that the y-coordinate is 0, and we have to solve to find the corresponding x. So into my equation, I'm going to put 0 for y. So I have 0 equals an opposite or negative x squared plus 5x plus 6. And now, if you were wanting to make the value of a positive earlier, and you couldn't, now is the time when you can. We're back to a quadratic equation with only one variable. We'd have a number here, not a y. Okay, so now we can do the kind of stuff that makes dealing with quadratic equations easy. You know, I'm going to go ahead now and multiply everything or both sides by -1. So I'll have 0 equals x squared minus 5x minus 6. And I'm going to now solve this quadratic equation. X squared minus 5x minus 6, that is factorable. That would factor into x minus 6 times the quantity x plus 1. And so my solutions are 6 and -1. Okay? So what does that mean? Remember up here we were saying, well, it should cross the x-axis twice. And getting these two solutions tells me it crosses once at 6 and once at -1. Or I have 2 x-intercepts. I have one point at 6, 0, and I have another point at -1, 0. Okay, if we plot those 2 points, so 1, 2, 3, 4, 5, 6, again, that all gels. It looks like I'm getting this nice symmetric parabola, which I should. Okay, and so then we can go ahead and just create the parabola through the points that we've found. So, when you're graphing doing this method, you know, find your vertex using what we've discussed. y-intercepts have an x-coordinate of 0, x-intercepts have a y-coordinate of 0, and you can just use your methods for solving quadratics that we've discussed quite extensively at this point. Let's do one more example, and then we'll end part 1. Going on, we'll still have some more to discuss. Okay, so here we've got one with some fractions. Don't be afraid of fractions, just go with it. So again, if I want to find the vertex, I can use this formula opposite of b over 2a only if my equation is in the form y equals ax squared plus bx plus c. Okay, which this is in that form. So if you want to use this formula for the x-coordinate of the vertex, you cannot get rid of those fractions. You have to leave them in there for now. Okay? So the value of a is negative 1/3, and the value for b is positive 1/2. So we have negative 1/2 over 2 times 1/3. Whoops, I wrote the wrong number. Or negative 1/2 over, if you multiply 2 by that's negative 1/3. If I multiply 2 by my negative 1/3, I'm going to get negative 2/3. And just get out your calculator and do negative 1/2 divided by negative 2/3. And when you do that division, you're going to get a positive 3/4. So the x-coordinate of the vertex is positive 3/4. Once we have the x-coordinate, then we substitute that back in. So we're going to take our 3/4 and substitute it back in for x to find the corresponding y-coordinate. So my y-coordinate is negative 1/3 times my 3/4 squared plus 1/2 times 3/4 plus 2, and again, just do it on the calculator so you don't have to worry about messing it up. So we have negative 1/3 times the quantity 3/4 squared, you see what I'm typing, plus 1 over 2 times 3 over 4 plus 2. And so we end up getting a corresponding y-coordinate. I don't know if you can see that, but that says 35 over 16. So the y-coordinate of the vertex is at 35/16. Okay? So 3/4, 35/16. That is our vertex. So plotting that 3/4, that's about 0.75, and 35 over 16, on this calculator, if you have a fraction and you want to look at the decimal, if you hit these double arrows, it'll give you the decimal conversion. So that's at approximately, or exactly 2.1875. So when we place this on our graph, so 0.75 is 3/4 of the way to 1, and then up 1, 2, and a little bit. So my vertex should be here someplace. Okay? Then if I'm thinking about, should this be opening up, should this open down, this is your vertex. So it's either going to go up like that or it's going to go down like that. And if a is a negative number, it opens down. If a is positive, it opens up. So this parabola, when I go out and find these other points, it should correspond to a parabola that opens down. Okay? So there's my vertex. I'm going to get that pointer out of the way. Finding my y-intercept where it crosses the y-axis, I know that it's got to have an x-coordinate equal to 0. So 0 is the x-coordinate. I substitute the x-coordinate in to find the corresponding y. So that's negative 1/3 times 0 squared plus 1/2 times 0 plus 2. which is 2. So it's going to hit the y-axis at 2. So I'm just barely below. And again, I can use my symmetry. I've got this axis of symmetry through that vertex. So 3/4 to the left, 3/4 to the right would be at 1.5. So there should be another point there. Based on the fact that it's opening down, I do know I'm going to have 2 x-intercepts. Let's find them. So the y-coordinate is going to be 0. So we put 0 in here and solve. So we've got 0 equals -1/3 x squared plus 1/2 x plus 2. Now that I'm back to a quadratic equation in one variable, now I can do the stuff of getting rid of my fractions, getting the value of a to be positive. So if I want to get rid of fractions, I can multiply by the least common multiple of 3 and 2, and that's 6. And also, I always like the coefficient of x squared to be positive, so rather than just multiplying by 6, I'm going to multiply by -6, and that's going to basically take care of 2 things at once. It's going to get rid of my fractions, and I'm going to have the value of a being positive. So I multiply everything by -6, right? All terms of the equation, that's really, I'm multiplying both sides. So I have 0 equals -6 times 0, 0. -6 times -1/3, we get +2. So that's 2x squared. -6 times +1/2, that would be a -3. So that's -3x. And then -6 times +2, we get -12. So that is -12. Now we need to solve. We can try to factor. We can complete the square. We can use the quadratic formula. Just because 12 has so many possible factors, I think I'm going to go ahead and just try to use the quadratic formula because I'm not sure that it will factor. So x equals, so we have a being 2, b is -3, c is -12. So the opposite of b, +3, plus or minus the square root, b squared is 9, minus 4 times 2 times -12, that's -24. All over 2 times 2, which is 4. So we have 3 plus or minus the square root of, so what would this be? 4 times 24, that would be 96. Is that right? And if I do 96, if I do 9 plus my 96, I get 105. All over my 4. Can I simplify? Can I reduce? So I have to think about 105. And I need to go through your list of perfect squares to see if any perfect square goes evenly into 105, and it doesn't. So 105, the square root of 105 cannot be reduced. These are real numbers, right? These are irrational numbers. They're crazy decimal numbers, but they are real. And no i's, right? No i's. This is a real number. And so I can, when I give the answer for what my x-intercepts are, I have one at 3 plus root 105 all over 4, and I have another at 3 minus root 105 all over 4. So typing that in, that would be 3 minus the square root of 105 over 4, comma 0. That's one of the x-intercepts. The other one is at 3 plus the square root of 105 all over 4, comma 0. Okay, but to be able to actually plot those, so those are exactly what the intercepts are. But to be able to place them, you're going to have to find a decimal approximation. So in your calculator, like I was saying before, if you type in 3 minus the square root of 105 all over 4 and hit enter, if you have this same type of calculator, it gives you basically the exact same thing back. But if you want the decimal approximation, if you hit these double arrows here, it'll convert that into an approximated decimal. So that's at approximately negative 1.8. Okay, so when I go to place this x-intercept, this is going to be at approximately negative 1.8. So back 1 almost to 2, it would be right about here. Same thing for this one. And I don't like to retype it all again. I would just come up to this, re-enter. You can highlight it, enter it, and kind of scroll back and change that minus into a plus. And so that's at about 3.311. So about 3.3. And so if I plot that, I go over 1, 2, 3, and a bit. And again, I'm looking at this, and this appears to be a nice symmetric shape. You know, it seems like what I'm getting here corresponds to a nice, pretty parabola. So I'm hoping that that means everything is on target. So you can go ahead then and make your graph using those points. So when you're graphing parabolas, make sure that you have symmetry. Make sure that all of these points create a nice symmetric parabola. If A is negative, your parabola should open down. If A is positive, your parabola should open up. If you have questions, let me know. We're going to do some more in the next part, but you might want to practice just a little bit first.